Alright, so in this video we're going to go over the basics of chemical bonding and then also how to draw Lewis structures. Alright, so a chemical bond occurs when you have atoms or ions that are strongly attracted to each other. So basically you have two atoms that come together and they stay together because they're attracted to each other. And usually that happens either because they transfer electrons or they share electrons. So an ionic bond involves the transfer of electrons. So because there's a transfer, one of the atoms loses electrons while the other one gains the electrons. So we have a positive charge and a negative charge, and they are attracted to each other because of that. So this will always happen between a metal and a nonmetal, or with polyatomic ions. So it's a cation, which is usually the metal because that's the positive ion. Metals usually lose electrons, and the nonmetal is usually the anion, which has a negative charge. Alright, so covalent bonds involve the sharing of electrons between two atoms. And that's always going to happen between nonmetals and nonmetals because nonmetals typically want to gain electrons. The only way that you can gain electrons with another nonmetal is if you share them. And then if you have a metallic bond, that is between two or more metal atoms. And basically what ends up happening is the electrons, the valence electrons, are pretty much shared amongst all the atoms. So it's free to move throughout the material. And this is why metals are conductive. That's because they're all sharing these electrons. So they are freely available to move, which is what electricity is. It's the movement of electrons. All right, so whenever we make a covalent bond, the atoms usually want to get 8 electrons. So that's what we call the octet rule. So they want to fill their S and P sublevels. Well, an S has a space for 2 electrons, and then P has the space for 6 electrons. So 2 plus the 6 in the P would be 8 electrons. So if you filled those S and P, then you create something that's more stable. Alright, so most atoms want 8 electrons, which fills the S and the P. Hydrogen only wants 2, and that's because hydrogen's electron configuration is 1s1. Well, with 2 electrons, you would fill it to make 1s2. So it would have a full energy level at that point. So it doesn't want any more than 2 electrons. And also, any element that's on period 3 or below that can have more than 8. They usually still want 8, but they can have more than 8. So that's called an expanded octet. And that usually happens with phosphorus, sulfur, and xenon. Although there are plenty of other atoms that can do this as long as they're on the 3rd period or below. And that's because they can open up that D sublevel to allow more electrons in. They don't typically want to do this, but they can. Alright, so groups 1, 2, and 3. So 1A usually wants just 2. 2A wants 4, and then 3A would want 6. So those are the exceptions to the octet rule. Most atoms want to have 8 electrons. So if we have a covalent bond, they're going to want to get 8 electrons unless it's hydrogen or groups 1, 2, or 3. Alright, so whenever you're drawing a Lewis structure, the first thing you should do is you should find out how many valence electrons you have available for bonding. Then you're going to find the number of octets. So basically, do they want to have 8 or do they want to have 2, or is it one of the exceptions? You're going to arrange the atoms. The singular atom will usually go in the middle, or the least electronegative atom. So electronegativity increases going up and to the right. So the least electronegative atom will go in the center. Never ever hydrogen though. Hydrogen will never ever be in the center. Then you're going to make bonds between atoms. So every time that you make a bond between 2 atoms, that's 2 electrons that are being shared. And then you're going to distribute the leftover electrons. So when you figure out how many valence electrons you have available, and you make your bonds, you're going to take the rest of the electrons that you have available and put those on the outside atoms to give them an octet. Extra electrons that you have afterwards go in the central atom. And if there aren't enough, you make double and triple bonds. All right, so these are my tips. And this should be in your note packet. You guys can read through those. We're going to go through all those tips as we draw Lewis structures anyway. All right, so we're going to draw CH4, which is methane. So the first thing I want to do, I want to find out how many electrons I have available. So for carbon, I have 4 valence electrons because it's in group 4, so it has 4 valence electrons. Hydrogen has 1 electron, and there are 4 of those. So I have 4 here, and then I have another 4 here. So I have a total of 8 valence electrons available for bonding. Then one of the tips that I give is to figure out how many bonds you're going to make in this molecule. Well, the one way you can do that, or one of the ways you can do that, is to figure out how many electrons do you want to have. So this would be what's available. You have 8 electrons that are available, and now I need to figure out how many electrons each atom needs to have. So carbon wants to have 8 electrons. Most atoms want to have 8, except for those exceptions that I went over, like hydrogen. Hydrogen is an exception. It only wants to have 2 electrons, and there are 4 of those, so that's 8. So my total needed electrons would be 8 plus 8 here, which is 16. So if I want to figure out the number of bonds, I can take my needed and then subtract out my available electrons. That gives me 8 electrons. Well, each bond is 2 electrons, so if I divide that by 2, I'm going to get 4. So I will have 4 bonds in this molecule. Now, you can always use this trick except for expanded octets. Expanded octets, it's not going to work. So if it's an expanded octet, you can't use this rule. And usually you can tell if it's going to be an expanded octet if there's more than 4 atoms bonding to a central. All right, so now we need to figure out what goes in the center. Well, okay, if you have carbon in the molecule, carbon will always go in the center. It likes to be in the center. It always makes 4 bonds. Or you can just simply look at it and say, okay, carbon is the singular atom, so that one should go in the center, which means all the hydrogens will bond to it. All right, so then the next step, I'm going to make my single bonds between the central atom and the outside atoms. So 1, and each line here will be 2 electrons. 2, 3, 4. So I've made 4 bonds. And let's count our electrons. It's 2, 4, 6, 8. Well, I only had 8 electrons available, so that means I should only have 8 electrons in my Lewis structure. So I do. I have 2, 4, 6, 8. Each line is 2. Well, let me make sure everything is satisfied. So carbon wants to have 8. 2, 4, 6, 8. It does. And hydrogen wants to have 2. So one bond would be 2 electrons. So each hydrogen has 2. So everything's satisfied. I've used all my electrons. That's my Lewis structure. All right, let's look at another one. Let's do F2, O2, and N2. All right, so F2. Well, if you look on your periodic table, we're going to look and figure out how many electrons we have available first. So fluorine is in group 7A, so that means it has 7 valence electrons, and there are 2 of those. So that means I have 14 electrons available. So let's figure out how many bonds I'm going to make. Well, each fluorine wants to have 8. There's 2 of them, so that's 16. So to figure out my bonds, 16 minus 14, needed minus available, equals 2. And then divide that by 2 because each bond will be 2 electrons, so it's 1 bond. And then if you look at my tips, usually the halogens will only make 1 bond anyway. So it's only wanting to make 1 bond in this one. All right, so I have 1 bond, but I have 14 electrons, so I need to distribute the rest of my electrons. So I've only used 2. I've got 12 left. So I will take the electrons and make lone pairs on the atoms. So 2, 4, 6. Now I have 2 electrons here. So 2, 4, 6, 8. It is satisfied. I will move to the next atom. So now 2, 4, 6, and then 8. So each fluorine atom is satisfied. It has 8 electrons, 2, 4, 6, 8. So now what I need to do is I need to make sure I've used up all my 14 electrons, and only 14. So 2, 4, 6, 8, 10, 12, 14. All right, so everything's satisfied. I've used up my electrons, so now I can move to the next. So let's look at O2. All right, so O2. So let's look at the available electrons. It's in group 6. So it has 6 electrons, and there's 2 of those, so that's going to be 12 that are available. And for needed, well, it wants to have 8. It's not an exception. All right, so now to figure out my number of bonds, 16 minus 12 would be 4 electrons. And then I'm going to divide that by 2 because each bond is 2 electrons. And that will give me 2 bonds. And then again, if you look at my tips, it says that oxygen and everything, and that's in group 6A, usually wants to make 2 bonds. So it's, if you have oxygen in your molecule, typically it's going to form 2 bonds. So O, I will make 2 bonds. 2, 4. All right, so now I've got 12 electrons. I've only used 4 electrons, so now I need to distribute to the atoms as lone pairs. So now 2, 4, 6, 8. So this oxygen is satisfied. I don't need to have another pair here because it's got 2, 4, 6, 8. So now I move on to this one. So 2, 4, 6, 8. So now each oxygen has 8 electrons, and I have used all 12. So 2, 4, 6, 8, 10, 12. So now I can move on. All right, so now let's look at N2. All right, so N2. For the available, I know that nitrogen's in group 5, so it has 5 valence electrons. There's 2 of them, so that's 10. Needed, well, it's not an exception, so it wants to have 8. So we have 16 needed. So 16 minus the 10 would give me 6 electrons. Each bond is 2, so I will get 3 bonds for this molecule. And if you look in the tips, nitrogen likes to make 3 bonds. So usually in the molecules, it's going to make 3 bonds. All right, so now I've got 2, 4, 6 electrons. So now I've got 4 more electrons to distribute. So 2, 4, 6, 8, it is satisfied. I move on. 2, 4, 6, 8, it's satisfied. So now I have 10 electrons